Hi, this is Chuck Benedict, mentor for Team 997 Spartan Robotics in Corvallis, Oregon. Back with another video to talk about the testable robot project that I've recorded several videos on in the past, kind of showing the path about how to take a command robot template and change it into something that can be testable using JUnit and Mockito. And where I kind of left it was because I had produced an example, a workable example, based upon the alpha code, the 2019 alpha code that WPI has released, um, and had eventually actually converted it to the 2019 beta code. And when I was in the process of testing it, I realized that since my team is not part of the beta program, I actually wouldn't be able to get a beta version of the image for the RoboRio, so I couldn't actually test that example that I started with. So that's why I haven't recorded video in the past week or week and a half, because I've been trying to get all these things straightened out. So I'm sure everybody's aware the WPI Lib is in active development, pending the build season for the year. So there's a publicly released alpha version of it that allows you to use some of the new features, but it's based upon last year's image. And then there's now, in recent weeks, a beta that was released. You can still use, the beta code for WPI is available in GitHub, but the image for putting it on the RoboRio, as far as I can tell, is not available unless you're part of the beta program, and we're not. So anyway, I have several revisions now in my repository of various versions of this project, kind of dealing with these various states. And I also wanted to mention that on the WPI repository, I put in a pull request for the testable robot example that I had been building and that we've discussed. It's not exactly what you see in the videos. If you watch them, I've made some modifications, but the ideas are basically the same. And I integrated it into the main WPI lib hierarchy and then made a pull request. So, hopefully WPI's got the time and will give me some feedback and can, if maybe not integrated before the build season starts, maybe they can get around to it while the season is ongoing, so that if you are interested in taking a look, you'll have the ability within the VSCode plugin to be able to create a new example, and this testable robot example will appear. So stay tuned for that. So that's all background. What I really wanted to talk about for this video was there's some feedback in the Chief Delphi post that I had made about making a testable robot program that talked about the fact that, gosh, that the dependency injection stuff you did was great, but, it creates a lot of artifacts and a lot of dependencies inside your main robot program and a lot of nasty object graphs and so forth. And yeah, I completely agree with that feedback. And that's one of the downsides of using dependency injection. Which I was aware of when I put the example together, but kind of wanted to do things step by step so that those that were watching could kind of see, how you get from step A to step B to step C. I think it's better to see the progression than to sort of just get it all at once. So this final video, what I'm going to demonstrate, and actually let me show you, let me make this a little bigger. There we go. Maybe not that big. So what you're looking at here is the robot.java program from the version that I submit to WPI, which is also the same version or similar version that I showed in some prior videos, where in order to, I have my systems and my subsystems and commands all accepting its dependencies or their dependencies through constructors. So in order to wire all that stuff up, you may remember that in the robot program, in the constructor of the robot program, I wired up all the dependencies for those subsystems and commands and command groups. And this led to, in the robot program, these kind of nasty looking object graphs of things that you needed to hold on to inside the robot program. So if we go back up here more toward the top, you can see that we have member variables of all of the various buttons and command groups and so forth. And these are things that you typically don't have to do. When you sort of do it the old way, you would just use a new command and create a new instance of either your commands or whatever, sort of wherever you needed them. And that, kept you from having to keep these things around as member variables. Of course, the problem is when you do that, you more tightly bind things together and it makes them untestable. So what I wanted to show in this video was a technique to clean all this stuff up, to actually make your robot program look more like what the old robot program looked like in the command robot example, while still retaining the benefits of using dependency injection for testability. So, and this revision, actually, before I go discuss how I managed to do that, in my GitHub project called Testable Robot, again, this will be in the comments of the video, so you'll be able to see it. If we look at branches, there's a branch called all WPI lib. This is actually a branch that mimics what I submitted to WPI for the testable robot example. This one called 2019 Cleaned Up DI, which stands for Dependency Injection. This is an example using the 2019 beta code with Google Guice, and I'll talk about Google Guice, with Google Guice implemented in it, but for the 2019 revision. Because remember, we got 2018 with 2019 alpha, and then we got 2019 beta. That's what this is for, and I created a separate branch for it because I can't test it. The tests work, but I actually can't deploy this example on a RoboRio yet. So the master branch, as it currently stands right now, goes against what's publicly available, which is the 2019 alpha using the 2018 image. So in that way, most all teams would actually be able to download master as it currently stands today. Today's December, 10th. You'd be able to go in, download master, put it on your RoboRio, and everything would work. The tests would work, the code on the RoboRio would work, everything would work. As time goes on and things get released, I'll probably change the stuff around to match whatever's currently released, but that's kind of where we are now. Okay, so if I switch over now to the master revision, and so what I wanted to show you then, before I get into sort of how this works, is that so now we're looking at robot.java, and we're looking at the constructor, and so now what you notice is all of that wiring up is now gone. We don't have to wire up our commands and command groups and subsystems and all that stuff. This sort of more resembles now what the default command robot template looked like. So we don't have to have any of that stuff in here. But what you will notice is this new call right here to Google Guice, creating what's called an injector. So Google, many years ago, I think this is probably 10 years old now, created a library called Guice, J-U-I-C-E. And what they created and what they realized is that you needed to use dependency injection for testability. That's kind of given even back then. But it requires you to take to either create these factory methods or to have all of this nasty wiring up of all your components. I like to call it ceremony. And some Google authors got together to create a dependency injection helper. I think that's probably the best way to describe it. Some people might call it an inversion of control container. Google really doesn't call it that, and I really don't think it's that either. There are frameworks like Spring that are really more robust inversion of control containers, and that's not really what this is. This is something much simpler. And for our purposes, it's perfect because we really don't need all that complexity. We just need some automated help wiring up our dependencies. So one other thing that I wanted to point out is, it used to be in the old command template, you would, this default auto chooser was wired up with a new command. So I think this used to say new example command or something like that. You can kind of see here what's been replaced by it. It's Injector get instance say hello command.class. So this may be giving you a little bit of inkling that the Google Juice mechanism is replacing the use of the new command, but instead you're calling into this thing called an injector to get a new instance to a particular class. So now in your code, you can use this kind of syntax to get the instances that you need where you need them, but still not still maintain testability essentially of your classes. So how does this magic actually all work? So one of the ways it works, well, and let's go look at a subsystem just to refresh, in case you haven't watched my other videos. It used to be with subsystems prior to using these techniques. If you had a piece of hardware in your subsystem, in the constructor to the subsystem, you would just call new on that hardware. And the problem with that is that binds your hardware directly to your subsystem, so it makes it hard to test. In prior videos, I had done all of this work where I accept these dependencies into the subsystem. So in this case, this subsystem takes a digital output. So instead of newing it inside the subsystem, I accept it as a parameter that we pass into it. I store it off as a member variable, and then later on I use it. So for dependency injection with Google Juice, this hello world subsystem actually does take a specific kind of digital output, and that digital output is bound to a specific kind of port. So what we do to make that happen is that we create what's called a named parameter with this arbitrary name. And later on, I'm going to show you where we wire up a named parameter and we tell Google Juice at the point at which you need a hello world subsystem, go look up this name parameter to figure out how to get the appropriate digital output that goes with this subsystem. And so as the coder, you don't have to specify that anywhere now. You would just reference the need for a hello world subsystem to exist, probably within a command, and Google Juice behind the scenes will actually wire it up for you. It's really kind of cool. So how does this named parameter get created? In Google Juice, there are these things called modules, and it is within the context of a module that you configure how the dependency injector is bound to either interfaces or name parameters and so forth. And that's done through what's called an abstract module. So you create your own module. You can call it anything you want. You extend it from abstract module, which is something that's in Google Juice. And you override the configure method. And so Google Juice, when you instantiate the injector, you're going to pass the injector this module, and then the act of doing that instantiation, Juice is actually going to call the configure method behind the scenes, and it is then within this configure method where all of the various bindings are going to be made. Now, most of the time when you use dependency injection, you're attempting to match up interfaces, and by that I mean a Java interface, to an actual implementation of a class against that interface. And it's through Google Juice that you do a bind from an interface to an actual concrete class. In WPI programming, at least the way it currently stands, as a robot programmer, there really are not that many interfaces that are provided to you. Mostly what you're doing is you're extending classes that already exist. You're creating concrete classes that extend from already existing concrete classes. And as far as Google Juice is concerned, it already sort of knows how to do that by default. So you wouldn't bind a concrete class to itself because Juice already knows how to do that. You actually can explicitly do that, and you can send something to the configure command that says, no, really make explicit bindings, make the programmer make explicit bindings in here for any class that Juice is even going to even think about doing a binding to, meaning concrete classes. I didn't go to that extent because I think it's just more work for really no gain. But there are some bindings that we do have to do, and namely, it's the bindings that relate to actually instantiating real hardware using name parameters. So let's look at some of these name parameters. And I actually talked about, in the Hello World subsystem, needing the digital output, the correct digital output wired up to be sent into the subsystem. So how do you wire up that name parameter? Remember this name parameter was called perpetual LED. So over here in robot module, so I'm binding the digital output class annotated with the name perpetual LED to something called a provider. And in Google speak, or Google Juice speak, a provider is a thing that provides a binding with an instance. So this is how then the binder works. The binder is given a anonymous function. There's a couple other syntactical choices you have, but I kind of like using these anonymous functions. I think it's easier to read. So the provider, you provide the provider with an anonymous function that simply does a new digital output with the correct constant referring to the robot map. And you'll notice here that's really all that I'm doing in this configure statement. I'm basically just wiring up hardware because these name parameters are sprinkled out through the rest of my classes, really the rest of my class constructor methods, where you need a specific piece of hardware to actually do the construction. Also note though that when I run my tests, a unit test in particular, this named parameter is ignored essentially by JUnit, or at least if you don't use dependency injection within JUnit for unit tests, which frankly you should not, this parameter is ignored and you can pass in whatever the heck you want here. You can pass in a mocked digital output the way you wish and perform your unit test just as I have in my past tests. Now, probably you should use dependency injection for integration tests because you're really sort of testing how you have dependencies wired up. I really don't demonstrate that in the examples that I've shown, but it probably would be a good idea for me to do that in a more maybe complex example, and I may yet do that, but realize my integration tests are not even using dependency injection, using Google Juice for dependency injection help at this point. I'm only using it in the main part of the program to show you how to clean up having to wire up all of those dependencies. So after you have your module wired up, really the next thing that you have to do is really back to the main robot program, as I had shown you. You create an injector, and that's really it. Google Juice will now, everywhere where you have an inject decorator, and I didn't talk about that, and I sure should. So you'll notice back over here in my subsystem, I have this decorator called inject. So Google Juice is going to go through all of your classes that are part of this project, and it's going to look for every constructor that you have decorated with an inject parameter, and it's going to try to figure out how to wire, with the configuration that you gave it in the configure method. It's going to try to figure out, okay, can I wire these things up? And again, if concrete classes are being wired up, it already knows how to do that. It is going to scan name parameters, and it's going to look to make sure that in your configure you have a name parameter named to match up with the parameters that you've given in your constructors. And by virtue of the fact that you've done this, you don't have to wire up any of the dependencies anymore. It just happens by magic. It's actually pretty amazingly cool. It makes your code clean. You don't have to create these massive object graphs of all of these dependencies. You don't have to litter your main robot program. with all of those variables. Really, you just have this injector here, and that's it. And in fact, if you'll recall in the prior videos, I factored out the OI, the operator interface class. I decided to go ahead and put it back in just to kind of make this example template look more like the template. And let's go ahead and open that operator interface so you can see the way this changes. So instead of having a constructorless OI class, I actually created a constructor. I pass in a couple of name parameters with some buttons and a couple of commands, and then I wire them up in the constructor of the OI class, again with the inject parameter, such that when I go then back into my robot class, inside robot init, where you may remember OI was being created with a new statement, now it's being created with the get instance statement on the injector. And again, by virtue of the fact that we have the inject decorator on the constructor for OI, magically Google Guice is going to create the correct OI instance, and it's going to stick it in this variable, which operates very similarly to how the template worked. So that's really all I have to say about the dependency injection. There's really a lot to learn about the use of Google Guice. I hope I did at least a little bit of some justice. Again, in the comments, there's a link to the Google Guice GitHub site, and in fact, there's a video, a very good video that I'll post the link to that you should watch. It's not all that long. Talks a lot about dependency injection and so forth. If you want to use these techniques, very much worth a look. And if you have questions, if I didn't explain this well enough, by all means, please leave me some comments, and I'd be happy to go into the use of dependency injection in subsequent videos. And with that, thanks for watching, and good luck.